Yes. Okay, we are going to subtract. What do we need to subtract? And, yeah, so we want to move everything to the left. Subtract x, subtract 10. Now, if you remember from inequalities, back in one-dimensional graphing, when you're dealing with inequalities, you have to be careful. Sometimes the sign flips. Does anyone remember when that happens? Yeah? By a? Negative. So did we divide or multiply by a negative when we subtracted x and subtracted 10? No. So we're good. I'm just going to put it in standard form with the squared first, then the linear, and then the constant, and the sign is still less than. Now it's less than 0. Okay? The important part of a quadratic would be the vertex. The vertex has something that runs straight through it. Good. Axis of symmetry. Do you want to remember the formula for axis of symmetry? Yeah?
Negative b
all over 2a. It's the beginning and the end of the quadratic formula. Yay! Axis of symmetry. X equals negative b over 2a. Negative b all over 2a. It's the beginning and the end of the quadratic formula. That's the way to remember it. Okay? Fingers in the air, what is b? Yeah, it'll be negative 1. So if we do a negative b, that will make it positive 1. Fingers in the air, what is a? 2. So 2 times 2 is 4. So 1/4 equals x. So that's the x coordinate of the vertex. If we know x, how do we find the y? Plug it in. Now when we plug in, we're not looking for where it's 0. We can change that 0 to a y. 2 times 1/4. You can do 1 divided by 4. Remember, fractions are just division. Squared. Make sure you have parentheses. Minus, parenthesis, 1 divided by 4, minus 10. That will be our y. It's 0 when we're looking for the x-intercepts. Hey, Brian. Justin, can you poke him? Sit up, please. Grab your pencil. Okay, grab your calculators, type that in. 1/4 squared is what, 1/16? Something like that. Make sure you use parentheses around fractions always. On the left-hand side, what does that become? Okay. Negative 10 point, what? 125?
Yeah.
125. So our vertex is 1/4, isn't that just 0.25? 1/4 is 0.25. Because graphing, decimals are easier than fractions. Okay, let's find that on the graph. 0.25 and negative 10. And a little bit. So like right just below the negative 10. Oh, wait. These lines, what are they counting by? Are they counting by 1s or 2s? They're counting by, nope, each horizontal line is counting by 1s. So this is negative 11, which makes this negative 10. So my point, the vertex will be right there. Okay, now I need a couple more points. How do I get a couple more points? So I see the parabola. The vertex you have to graph, and then I need to see the parabola. Ooh, we could do that. We could use our ratios. 2/1, and what's the other ratio? 4/2. We could use the ratios. What's another way to get some points? This is a quadratic. We could find the solutions, which means you could try factoring it and using the 0 property, or you can use our friend. It's negative b. Quadratic formula. Because especially with decimals, I don't know if my zeros are going to be pretty. If we try factoring only works if the zeros are pretty. So let's try the quadratic formula. We just need 2 more points. So it's negative, what's b? So negative 1 plus or minus, Brayden, can you bring that up to me, please? Square root What comes after the square root? B squared. Yep. B squared minus 4AC. Fill it in, please. B squared minus 4AC, but with the numbers. Make sure you have parentheses around that negative 1 squared. Minus 4AC is a negative as well. All over 2A. Okay, what's the discriminant? 1 times minus, what's negative 4 times 2 is negative 8 times a negative 10 is a positive 80. So 1 plus 80 would make 81, which means it's a positive, so we should have 2 real solutions. And square root of 81, that's actually a really nice number. Not just 9. Plus or minus 9, we should get 2. So we're going to have 2 answers. 1 plus 9 divided by 4. And 1, what's the other option? Minus 9 divided by 4. Add and subtract before you do the division. Raise your hand when you know both of the x-intercepts. Okay, raise your hand when you know both intercepts. You know both? Raise your hand when you know both intercepts, please. Okay, I think the front of the classroom is winning. Raise your hand. There we go. There's some more. Raise your hand when you know both intercepts, because you've done 1 plus 9 and then divided by 4, and 1 minus 9 and divided by 4. And what's that last one? Good. And this one you need to do subtraction first. 1 minus 9 is negative. See what happened? You didn't put parentheses. You need to do parentheses around the numerator because it comes out as negative 2. Yep. So if you are, this is actually a really good conversation point. If you're doing this with your calculator in one full step, there has to be parentheses around the numerator. Okay? The top one, Jessica, what'd you get for the top? 2.5. Good. X equals. So that's an x-intercept. And Sammy, what about the bottom one? Negative 2. X equals negative 2. So, one of them was a nice number, and mine's kind of hard to see. I think negative 2 is right there. And 2.5, oh no, 1's right there. My bad. Is yours printed better? Can you actually see yours? Negative 4, that must be negative 3, negative 2, 1, 1, something like this. It's not printed very well. So 2.5 is on the x-axis, and negative 2 is on the x-axis. And then make sure you go through that vertex and it's curved parabola. Ooh, but there's one change. Before you draw that parabola, you might want to listen up. This is an inequality. If you remember with inequalities on a number line, there's differences between open and closed circles. Do you remember the difference? Open circles for what type of inequality symbols? Less than and greater than. Closed is for the equals. So same thing here. Less than and greater than will be open, which means a dashed line. Less than or equal, greater than or equal will be a solid line. So in this case, which one do we need? The dash, because it's just less than. So I'm going to take my eraser. You can just take your eraser, and if you've done it in pencil, and just kind of erase certain portions so it looks dashed. Like that. Okay. We're going to do method 2. Down below on example 6. What? Yeah, we just did method 1, example 6. This is method 2, example 6. This is a lot of what your homework is like. Okay, now we have two functions. The first one has an x squared. What type of functions are x squareds? Quadratic. The second one has x to the first power. What type of functions are x to the first power? Linear. So our last assignment we were dealing with quadratics and linears. So we have two that are going to intersect, probably. And where they intersected, last time we found the solutions. This time we want to solve for where the intervals where f is less than g. Okay, so we need to graph both of these. F of x equals 2x squared. The vertex. This should be an easy one to see with your eye. Because remember, I'll write it over here. Vertex form, a times x minus h squared plus k. We have our vertex opposite same. What number is with the x inside parentheses being squared? What number is with the x inside parentheses being squared? 0. Because the 2 is the a. The 2 is the multiplier. So x plus 0 squared. And what number is after the squared? 0. So the vertex is 0, comma 0. The vertex is at the origin. 0, comma 0. Okay? And we need a couple more points. You can use a table, 0, comma 0. Make sure the vertex is always in the middle. And then we need a couple smaller and a couple bigger. But because of symmetry, we really only have to do 2. And we can know the other 2 because of symmetry. Let's do the positives, because that would be easier. If we plug in positive 1, Alfredo, what will my y be? If I plug in positive 1, I get, 2x squared. I replace x with 1, so it'll be 2 times 1 squared. So it's 2 times 1 squared, like that. Just the 1's being squared. So 1 squared is 1. Then we times by the 2, which is, there you go. Alright, you got it. Okay, now we do the same with 2 squared. We have to do exponents first. Okay, Sean, what's 2 squared? Times by the 2, we get 8. And because of symmetry, we know these negative 1 will be a 2, and negative 2 will be 8, because of symmetry around the vertex. Okay, so let's graph those. And this is an equal, so we don't need to worry about dotted or dashed. It says equal. Negative 2. Yikes. Okay. Notice negative 4 is way out here. And this is really awfully printed. I'm sorry. Just mark it. Make sure you mark it so you know where is where. I'm not going to use that negative 4 way out there. Oh, I get it. This 1 is kind of in a weird spot, because this 1 is fine. 1, 2, 3, 4. Negative 1 should really be there. Negative 2, negative 3, negative 4. Okay, and it looks like these lines are counting by 1s, because there's a little 1 there, all the way up to 12. So we need to plot the vertex 0, 0. And we need to plot negative 1, 2. Negative 2, 8. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That works. Okay. Negative 2, 8. Man, this is really poorly printed. I'm sorry. I think yours is slightly better than mine. 1, 2, and 2, 8. Okay. Now because it's equal, we can put a solid parabola. Now we need to graph g of x. And this is f of x. So if you label f of x. And then we need to do another one, which is g of x. This is a linear function. Do you guys remember how to graph linears? I have a whole song and dance for this one, too. What is y equal mx plus b? Like YMCA. What is m? is M? Slope. And that is rise over run. And what is B? The y-intercept. So you start with the y-intercept and we go find positive 10 on the y-axis. And you put a nice solid point there. This is linear, so it's going to be a line. From the y-intercept, I use the slope. So what is my slope? 1 over 1, because in front of the x, it's 1x. So our slope is 1 over 1. I'm going to rise 1 and run 1. Rise 1 and run 1. Which also means I can go down 1, left 1. Down 1, left 1. And there should be an intersection right there. Down 1. Left 1, down 1, left 1. And this is also an equal, so it's solid. So this is g of x. You should label. This one's g of x. Put a little g of x right next to it. It wants to know when is the parabola, and mine's green, the f of x less than g of x. What does it mean to be less than? Okay. Yeah. Graphically, visually, what does less than mean? Below. Good. So we want to know when is the green f of x below the red. There's an interval. When does it first go below? Tell me when to stop. When do I first drop down below? Here, right? At -2, right? And when do I finish being below? Right here. So, yeah, it's probably at positive 3. We'd have to definitely plug into the 3 to make sure. So next time, I'm going to leave that right here because that's all we have time for. Next time we'll be working out writing those intervals of time. So I'm not going to give you the worksheet because we're not quite ready for it. But you do have those 6 problems in the book. Okay, on quadratic regression. Next time, please bring these notes. Also bring your honors version of the book next time. Okay?